Good morning to all of you. Today we will discuss engineering mechanics. Last class we have completed 40 number of classes. This class is 41. We have already discussed what is momentum, impulse moment equation. Just I will recall the subjects, the topics, and I will start. What is law of conservation momentum? What is the impulse moment equation? Clear? So what is the momentum? Momentum. The momentum of moving mass, the momentum of a moving body is the amount of motion, is the amount of motion possessed by body, possessed by the body, and is equal to the product of mass and velocity of the body. Velocity of the body. There. That is momentum P is equal to m into b, mass into velocity. Clear? Where m is equal to mass of the body, m, b is equal to velocity of the body, and p is linear momentum. P is equal to linear momentum. Clear? Now impulse. Impulse. What is impulse? Impulse is equal to product of force and time. The impulse is defined as the product of force applied on the body and its time, that is impulse I is equal to F into T. What is unit? Newton second. Suppose a body moving from A to B, U is the initial velocity of the body, U initial velocity, B is your final velocity, T is your time taken by the body, time taken to move from A to P. Consider a body moving in a straight line from A to B, from A to B, A to B. Clear? Let U is equal to initial velocity of the body, U. B is equal to final velocity of the body. Clear? U initial velocity, B final velocity. T is equal to time taken from A to B. T is equal to time taken from A to B. Clear? M is the mass of the body. M is equal to mass of the body. Mass of the body. Now, what is initial momentum? M into U. What is final momentum? M into B. What change of momentum? Final momentum minus initial momentum. MB minus MU. Now, initial momentum M into U. What is final momentum? The same mass with M. Final momentum M into B. Right? Change of momentum. Change of momentum MB minus MU. This will M into B minus U. Rate of change of momentum. Rate of change of momentum is equal to M into B minus U by T. Clear? According to second law, the rate of change of momentum is equal to impulsive force. The rate of change of momentum, the rate of change of momentum is equal to the impulsive force. Impulsive force. That is, what is F is equal to M into B minus U by T. Clear? So F into T is equal to this implies I is equal to F into T is equal to M into B minus U. Clear? F into I, M into B minus U. This is called impulse momentum equation. This is known as impulse momentum equation. I is equal to F into T is equal to M into B minus U. This implies what is I is equal to Fmt is equal to mv minus mu is equal to final momentum minus initial momentum, that is called change of momentum. This is equal to change of momentum. Clear? Hence, the impulse is also defined as the change of momentum of the body. This is known as impulse moment equation. I is equal to Fmt is equal to m into v minus v. Clear? Now we will discuss what is law of conservation of momentum. Now the topic is law of conservation of linear momentum. Linear momentum. Clear? Suppose we consider two bodies. This is body 1, body 2. This is before collision. This is during collision. Suppose this is after collision. Right? This is body 1, body 2, M1, M2, both are moving in same direction. So this is U1, U2, U1, U2. So this is before collision. This is during collision. This is after collision. Clear? Before collision, during collision, after collision. So two bodies, 1, 2, this is 1, 2, 1, 2. So before collision, its velocity is U1 and U2. Here, U1 is more than U2. Where is more than U2. After collision, its velocity is V1 and V2. V1 and V2. Here, after collision, V2 is more than V1. Clear? This is action F1, this is reaction F2. F1, F2. Action F1, reaction F2. Now, action plus reaction is equal to 0. F1 plus F2 is equal to 0. Now, I will write definition. What is law of conservation of linear momentum? Again, I will explain you. two bodies moving with velocity u1, u2. Before collision, its velocity u1, u2. After collision, its velocity v1, v2. This is during collision, during impact, f1, f2. Clear? f1 plus f2 equals 0. f1 action, f2 reaction. Now, law of conservation of linear momentum. The law states that if the resultant external force acting on the system is 0, then the total linear momentum of the system is conserved, that is constant. Clear? That is m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. I will prove this. Consider two bodies 1 and 2. This is 1, this is 2, moving in a straight line. S1 figure. Clear? Let m1 is equal to mass of body 1, m1. m2 is equal to mass of body 2, u1 is equal to initial velocity of body 1, u1, before impact, before collision. ut is equal to initial velocity of body 2. That means this is before collision. So before collision, u1 is more than u2. So u1 is more than u2. If u1 is more than u2, then only two body can be collide each other, or the collision takes place. Clear? So initial momentum of first body, before collision, m1 u1. Initial momentum of second body, initial momentum of second body before collision M2 U2 M2 U2. Now total initial momentum before collision. Now total initial momentum before collision is equal to M1 U1 plus M2 U2. Equation 1. Equation 1. Now, since U1 is more than U2, then collision takes place. Let after collision, its velocities are V1 V2. This figure 1, figure A, figure B, figure C. Clear? Here action F1, reaction F2. So after collision, V1 V2 is the final velocities with two bodies. So let the collision takes place. Collision takes place. Clear? Let V1 and V2 is equal to final velocity of two bodies after collision. Clear? So before collision U1 U2, after collision V1 V2. Now, so after collision, what is final moment of first body? M1 V1. What is final moment of second body? M2 V2. Now, after collision, final momentum of first body M1 V1. Clear? Similarly, final momentum of second body M2 V2. So the total final momentum after collision M1 V1 plus M2 V2. Total final momentum after collision is equal to M1 V1 plus M2 V2. This equation 2. Clear? Initial momentum total M1 V1 plus M2 U2. Final momentum total is equal to M1 V1 plus M2 V2. Now we will prove total initial momentum is equal to total final momentum. That is M1 V1 plus M2 U2 is equal to M1 V1 plus M2 V2. Now I will prove this. Let let the collision takes place for t second. For t second. Now, rate of change of momentum, rate of change of momentum rate of change of momentum of first body is equal to m1 v1 minus m1 u1 by t. Clear? Similarly, this f1. Similarly, rate of change of momentum of second body is equal to m2 v2 minus m2 u2 by t. Clear? This is called action, this is called reaction. Now action f1 is equal to, now action f1 is equal to m1 v1 minus m1 u1 by t. Similarly, this is reaction. Reaction f2 is equal to m2 v2 minus m2 u2 by t. Clear? This action, this is reaction. So according to Newton's third law, action plus reaction is equal to 0. Every action has equal and opposite reaction. That is, action plus reaction is equal to 0. If no external force, acts on the body, clear? Then according to Newton's third law, action plus reaction is equal to 0. That is, f1 plus f2 is equal to 0. This implies, what is f1? m1 v1 minus m1 u1 by t plus m2 v2 minus m2 u2 by t is equal to 0. Clear? So take this other side. Or take LCM t, m1 v1 minus m1 u1 plus m2 v2 minus m2 u2 is equal to 0. Clear? So 0 to t equals 0. Now m1 v1 minus m1 u1 plus m2 v2 minus m2 u2 is equal to 0. Take m1 u1 plus m2 u2 that side. Now m1 v1 plus m2 v2 is equal to m1 u1 plus m2 u2. This implies m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. What is this? In total initial momentum. This is total final momentum. This equation 3. This equation 3. Therefore, this implies total initial momentum is equal to total final momentum. Clear? That is, the total linear momentum system is conservative. That is, the total linear momentum of the system is conservative. Clear? This is law of conservation of linear momentum. Now I will explain what is impact. What is the plastic impact? What is elastic collision? Clear? What is coefficient restitution? Now I will detail discuss regarding this topic. Now elastic collision. In similar way, we consider two bodies, 1, 2. This is body 1, this is body 2. This is before collision. This is figure B after collision. This is figure C during collision. This is figure C after collision. Right? This is figure 1, figure A. Before collision. This is figure B during collision. This is figure C after collision. Now, so before collision, its initial velocities are u1 and u2. u1 and u2. After collision, its final velocities are v1 and v2. Right? This is body 1, body 2, 1, 2, 1, 2. So, this is before collision. Body figure 2 is during collision. and figure C is after collision. Clear? So before collision, its velocity u1 and u2. So here u1 is more than u2. Then only can collide each other. If u1 is more than u2, then body 1 can collide with body 2. So figure B will come to place. This action, this reaction, F1, F2. So F1 plus F2 is equal to 0. So this is after collision. After collision, the velocity of body 2 is more than the velocity of body 1. That is, V2 is more than V1. Because body 2 is moving with some velocity and body 1 will strike, will collide with body 2. So naturally, the body 2 velocity increases. So before collision, its velocity u2. So after collision, its velocity v2. So before collision, u1 is more than u2. After collision, v2 is more than v2. Clear? This is mass m1. This is mass m2. m1 m2 m1 m2. Consider two bodies, 1 and 2. 1 and 2, having mass m1 and m2. m1 and m2. Clear? Moving in a straight line. Moving in a straight line as shown figure. As shown figure. Clear? Let u1 u2 is equal to initial velocity of two bodies before collision. Before collision. Now u1 is more than u2. Clear? More than u2. Now the collision takes place and the body moves with velocity v1 and v2. Let the collision takes place. Collision takes place. Clear? And v1 and v2 is equal to final velocity of two bodies after collision. After collision. So here v2 is more than v1. Right? Now total initial momentum before collision is equal to m1 u1 plus m2 u2. Similarly, total final momentum after collision is equal to m1 v1 plus m2 v2. Right? According to law of conservation of linear momentum, right? m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Clear? The same place. The same place. m1 u1 minus m1 v1 is equal to m2 v2 minus m2 u2. Clear? The same place. m1 into u1 minus v1 is equal to m2 into v2 minus u2 is equation 1. Equation 1. Clear? Let the collision is perfectly elastic collision. Clear? That is the current energy of the system is conserved. Clear? That is K before collision is equal to K after collision. That is current energy, that is total K before collision is equal to total K after collision. Right? This implies what total K before collision? Half m1 u1 square plus half m2 u2 square. This is before collision. What is after collision? Half m1 v1 square plus half m2 v2 square. Clear? This is before collision, this is after collision. Half cancel out. This implies m1 u1 square plus m2 u2 square is equal to m1 v1 square plus m2 v2 square. Clear? So come being m1 v1 square this side, m2 v2 square that side. This implies m1 u1 square minus m1 v1 square is equal to m2 v2 square minus m2 u2 square. Right? This implies m1 into u1 minus v1 into u1 plus v1 equal m2 into v2 minus u2 into v2 plus u2. This equation 2. Now this equation 1, this equation 2. Now equation 2 by 1. 2 by 1. What 2? m1 into u1 minus v1 plus u1 plus v1 by equation 1 by m1 into u1 minus v1 is equal to m2 into v2 minus u2 into v2 plus u2 by m2 into v2 minus u2. Clear? So m2 cancel out, m1 cancel out, u1 minus v1, u1 minus v1 cancel out, v2 minus u2, v2 minus u2 cancel out. Clear? Now u1 plus v1 is equal to u2 plus v2. Clear? This implies u1 minus u2 is equal to v2 minus v1. Clear? This equation 3. Equation 3. So what is u1 minus u2 is equal to, so u1 minus u2 is equal to velocity of approach before collision u1 minus u2. What is v2 minus v1? Velocity of separation after collision. Right? Now, so in case of elastic collision, velocity approach before collision is equal to velocity approach after collision. Clear? This is BA, this is equal to BS, this is equal to BA to BS. So in case elastic collision, B approach is equal to B separation. Now solve equation 1, 2, 3. This equation 1, 2, this equation 3. So on solving, we will get B1 is equal to, or B2 is equal to 2 M1 U1 by M1 plus M2 plus M2 minus M1 by M1 plus M2 into U2. Clear? 2 B2 is equal to 2 M1 U1 by M1 plus M2 plus M2 minus M1 by M1 plus M2 into U2. This is B2. Similarly, B1 is equal to M1 minus M2 by M1 plus M2 into U1 plus 2 M2 U2 by M1 plus M2. Clear? This is B1, B2. What is B1 is equal to? M1 minus M2 by M1 plus M2 U1 plus 2 M2 U2 by M1 plus M2. This is equation 4. Now, we'll use the following equation, the above equations to solve problems. Now, I will discuss what is coefficient of restitution E. Coefficient of restitution. Coefficient of restitution E. Clear? The coefficient of restitution, the coefficient of restitution is the measurement of, is the measurement of degree of elasticity in a collision. In a collision. Clear? It depends on the measurement of degree of elasticity in a collision. It is measured as the ratio of, it is measured by the ratio of, velocity of separation after collision. Ratio of velocity of separation after collision to the velocity of approach before collision. Before collision. Clear? Separation by approach. That is E is equal to E is equal to velocity of separation after collision by velocity of approach before collision. Clear? That is E is equal to Bs by Ba. What is Bs? B2 minus B1 by B1 minus B2. B2 minus B1 by B1 minus B2. This is the coefficient of restitution. For perfectly elastic collision E is equal to 1. E is equal to 1. For perfectly inelastic collision E is equal to 0. E is equal to 0. That means E lies between 0 and 1. That means E lies between, this means E lies between 0 and 1. 0 and 1. Clear? Now, this is perfectly elastic, inelastic. But for semi-elastic collision, E is less than 1. Is less than 1. Clear? Now I will discuss what is plastic impact or plastic collision. This is about elastic collision, inelastic collision, semi-elastic collision. Now I will discuss what is plastic collision or plastic impact. Plastic collision. So in case of plastic collision, after collision, both the bodies will move with the same velocity. Suppose this is two bodies want to, this is before collision, this is after collision. Clear? So before collision, its velocities are u1 and u2. u1 and u2. After collision, both the bodies will move with velocity v. With velocity v. Clear? So before collision, its mass are m1 and m2. After collision, both body move together. So total mass is m1 plus m2. right? Before collision, its mass is m1 m2. So after collision, both the bodies moving with same velocity. So its common velocity is v, and total mass is m1 m2, m1 plus m2. This is before collision. This is after collision. Clear? So, what is plastic impact? In case of plastic collision or impact, both the bodies after collision will move with same common velocity. Same common velocity. Let after collision both the bodies m1 plus m2 move with the same common velocity v. Let let m1 and m2 mass of two body before collision or mass of two bodies. Here u1 and u2 is equal to u1 and u2 is equal to initial velocity of two body before collision. Clear? So before collision, u1 u2 mass m1 m2. So after collision, this is before collision. Right? So after collision, what is mass of two body? m1 plus m2. m1 plus m2 is equal to mass of or total mass of bodies. Total mass of two bodies. m1 plus m2. And v is equal to common velocity. Common velocity of two bodies. Right? So what is momentum before collision? Now momentum before collision is equal to m1 u1 plus m2 u2. Clear? This equation 1. Momentum after collision. Momentum after collision is equal to m1 plus m2 into B equation 2. Right? According to law of conservation linear momentum, according to law of conservation of linear momentum, total momentum before collision is equal to total momentum after collision. Right? This implies equation 1 is equal to equation 2. Clear? What is equation 1? M1 U1 plus M2 U2 is equal to M1 plus M2 into B. What is B is equal to M1 U1 plus M2 U2 by M1 plus M2. This is common velocity after collision B. Clear? So this is for mass. If mass is given question, you can apply this equation. If weight is given, then WR1 plus W2 is equal to WR plus W2 into B. This implies what B is equal to WR1 plus W2 by WR plus W2. Clear? This completes our theory of law of conservation of linear momentum. Next class, I will do some problems regarding this theory.